In the following examples, we are going to take a look first at angular speed, and then we're going to talk about linear speed in relation to angular speed. So let's think about this for a second. We've got angular speed. This is the rate at which the angle is really changing, all right? And it's in unit of radians per unit time. So theta has to be in radians. So if you're dealing with degrees, you must be sure to convert. And so all you have to do is take your angle and divide it by the unit of time of which you're changing. Okay, so in this first example, we are asked to calculate the missing value. And in this case, we're missing this, it looks like a W, but it's omega. And omega is what we call the angular speed. All right, so if we are looking for omega in this example, all right, and that is a weird looking omega. Let's see if I can do better. That's as good as it's going to get. All right, we're going to take pi over 2 and we're going to divide it by 7. But remember, when dividing fractions, you've got to keep, flip, and change. So you're going to have pi over 2, in this case, times 1/7. Now, no need to pull out the calculator for this one. It's simply going to be pi, because pi times 1 is pi, divided by 2 times 7, which is 14. So it's going to be pi over 14 radians per second. So this is the angular speed. Some may even say angular velocity. Okay? All right. Now let's take a look at the linear speed. So the linear speed is the product of the radius times the omega, the angular speed. Okay, so there's also another way to look at it, and this is if you take the arc length and divide it by the unit time. So that may be a possibility of a problem you may see. And also remember that the arc length, S, equals r theta, so it is also r theta divided by time. All right, so this is something to think about, all right, because remember the unit theta over time is omega. All right, so there's the connection about how all of these are related. So we found out over here omega was theta over time. Well, theta over time is omega, and since we're multiplying r times theta on the top, that is equivalent to saying the arc length divided by time. Okay, so just kind of keep that in mind, the relation between all of these right here. Okay, so let's take a look at an example, and I am going to see here if I have a linear speed of 11 feet per second, and I've got a radius of suppose 9 feet. All right, I want to know, well, what is my angular speed? Okay, so how can I do that? Well, I know V equals R omega. So V equals R omega. I know V, I know R, so I'm going to have to manipulate the formula, and I jumped the gun there. Omega then is going to be the velocity, the linear speed, divided by the radius. Okay, so there's my omega. So in this case, when I've manipulated it, I get 11 feet per second divided by 9 feet. My feet unit cancels out, leaving me with, now it doesn't give us the unit of the angle, but we know of course it's radians. Okay, so it's 1.2 radians per second. So this right here is the angular speed given a linear speed and a radius. So really quite nice examples here, but the important takeaway is seeing how all of these formulas here are connected and how we can use them together. So keep that in mind as you progress through this section, and know that you may have to manipulate the formulas. So if this video was helpful, I do encourage you to like and subscribe. So thank you very much for watching.